This is LUO, the first multimodal portable mobile robots. LUO has 4 steering modes that can easily be switched in just 3 minutes: 4-wheel differential steering and Ackerman steering, track steering, omnidirectional steering. LUO can easily tackle different indoor and outdoor scenarios to make your robotic world mobile. With high-performance AI modules, LUO can realize simultaneous localization and mapping, autonomous path planning and navigation, object detection, and obstacle avoidance to see, understand, and interact with the real world. Based on open source software and ROS, you can use LUO to build a VSLAM spatial map for survey and monitoring functions. If you're a beginner or just an enthusiast developer, don't worry. A beginner-friendly simulation table and rich ROS package are provided, so you can quickly learn ROS to develop new autonomous functions. LUO is the perfect tool for educational programs to learn more about robot programming, AI development, and real-life applications. LUO integrates high-performance sensor modules and rich expansion interfaces that enable autonomous driving systems for more AI possibilities. With a user-friendly raw platform, LUO Lite, you can fully design the robot by yourself any way you can imagine. Now, get LUO and create your own mobile AI robot.
Thanks. So this time, we will introduce LUO in 4 parts to let you know more detail about it. The LUO comes ready to use out of the box. In terms of dimension, you will see it's really small and really suitable for the table use. Only 4.8 kg weight. One person can easily to pick it up. Also, the hub motor makes the strong movements that can be climbing 25 degrees. The standard version of LUO will be controlled by the app, but no worries, the remote controller still will be the option for you. LUO is integrated with 2D LiDAR, camera, onboard computer, speaker, displayer. Also, we have built a simulation table for LUO, so the client can do their research and development on table, make the job easier. The standard version will be just a nano for the ROS one. To get closer to the new technology, we also can provide the customized version, which use the Orin Nano or the Intel NUC computer for the ROS 2. Why is so special? As we all know, in all robots, the most basic motion modes are divided into 4 types: differential steering, Ackerman steering, omni-magnetic steering, train differential steering. In the past, if we need to know more about robots, that means we need to order at least 4 robots. But for now, we have created the first multi-mode robot in the world. So LUO has 4 different motion modes. We just need 1 robot can do all of them. For the LUO, we standardize the robot platform, not only giving it the super powerful hardware, but also the open source software. LUO is support ROS 1, ROS 2, Python. We are also providing simulation package to the client, make the development easier. So you will be able to use LUO for learning. For example, SLAM, VSLAM, navigation. Next, our engineer Jean will share more development experience. Welcome.
Okay, hello everyone. This is Jean, technical support engineer from AgileX Robotics. Thanks TechShare team this event. Thanks my colleagues for the first part presentation. Next, I will introduce some application of LUO. In this part, let's talk about Jean mapping. It is a commonly used open source land algorithm based on the filtering slave framework. Jean mapping is used to build ordinary information and don't require high frequent data from the LiDAR. And in LUO, we use the ROS Jean mapping package to mapping. And this is the interface for the mapping and navigation. Use Jean mapping. As you can see, these two processes from these two videos. Yes, you can see these videos. And the next is cartographer is the laser mapping. The cartographer is a set of graph optimizing slang algorithm launched by Google. And the main goal of this algorithm is to achieve low computing resource consumption and achieve purpose of real-time slang. And below is the interface for mapping and navigation that use the cartographer. And you can see the two processes from these two videos. You can see this video. The left side is the laser mapping, and the right side is navigation mapping. Okay, and the next is visual mapping and navigation. Using the AgileMap algorithm and the real-time map algorithm provides a time and scale independent solution for appearance based on the positioning and mapping. The idea of the solution is to use only a limited number of the positioning points, and it can assess the positioning points of the entire map when needed. So, to meet real-time performance, it can meet the real-time performance. And below is the interface for mapping and navigation. Use the AgileMap. You can see these videos. The left side is the visual mapping, and the right side is the visual navigation. Okay, go to this part. In terms of the visual applications, we have vertical 4 functions: traffic light detection, lane checking, object detection, and the QR code recognition and checking. Let's talk about the latter recognition by get RGB images from the camera. Doing some specific processing on the image, then use the Python text recognition library to recognize the letters, numbers in the image. And then you need to publish the recognition results to the text word result public. And next is the traffic light detection based on the LUO depth camera. After forming object detection, use the .NET ROS. We need to identify the color of the traffic lights located in 3-dimensional space. Then generation the positional relationship between the object and the camera to realize the recognition and the position to traffic lights. At the same time, we have also developed visual inspection and object tracking based on the LUO depth camera. You can see the actual performance in the video, in this video, and as you can see, the left side is the visual inspection, and the right side is the depth camera and the lane tracking. Yes, you can see the efficiency is very good. And the next, in order to make it easier for customers to learn the roles, our company has also developed the simulation in the guidable. It allows beginners to realize the laser mapping in the navigation positioning in guidable when they are learning roles. And in addition, we have also set up a city simulation sandbox. Through this sandbox, we can achieve multi-scenario virtual teaching and testing. All the functions of the LUO are developed based on this sandbox. It can run the above functions in the sandbox perfectly, and it can better help beginners considerate and learn roles. Okay, let's go to this part. As you can see, we have jointly developed a set of courses with the ROS learning community in China. And this course series is designed to help beginners with their experience in ROS, and it can help them quickly get started. It is divided into parts. As you can see, the left side is the practical courses, and the right side is paid premium courses. Yes, this is two courses for the LUO. And let's go to the next part. In the future, we will also, based on the road to humble, to developing LUO and LUO core lines based on the road to humble. And the LUO will equipped with an NUC force and will use the Ubuntu 22.04 system, and it's developed based on the road humble. On LUO, we will realize functions such as lane mapping, auto navigation, obstacle avoidance, traffic lights illumination, visual tracking, and lane inspection. And we will upgrade from Dragon Nano to Dragon Orin Nano. Additionally, we will mount a robotic arm on the top of LUO, enabling it to have grasping ability. We have also enriched the LUO courses to allow beginners to learn more skills and expand their knowledge. Yeah, and the application and functions on those two of LUO will be more for education and basic scientific research in the future. If there are higher requirements for functions developed based on roles, we have the road to navigate to achieve these higher requirements. And in the next part, I'm going to introduce the road to navigate to you. Yes, let's go to the next part. Next part is road to navigate. Yeah, and in this part, I will introduce the route to navigate to you. And first, let's watch a video of the route to navigate. Yes, let's watch a video. It's auto navigation and avoidance and upstate avoidance. Yes, it's visual and laser navigation and mapping. You can see this video. It's the process, the visual and the visual navigation. You can see a text in the map. Okay. After watching this video, I believe you all have got a firstly understanding of the road to navigate, and I will show you 5 sections of road to navigate, and it's including key introduction, key configuration, introduction to road to mapping and navigation example, and the environment steps in this part. Okay, let's start with section 1. The road to navigate is the basic level version, and the advanced kit for road to environment. It is customized for road to scientific research and education application. It integrates a high-performance computing unit, LiDAR, and multiple sensors to realize many applications of mobile robots. At the same time, we also provide numerical documentation, demo resources, and custom sensors mounting bracket. And this kit is best compatible for the road's secondary environment. And currently, we have adapted the road toolkit to the Scout Mini, and in the future, we will gradually adapt to into more surface. For this presentation, we will use the Scout Mini as presentation. And next, let me introduce the configuration of the road kit. There are 2 configurations for road toolkit: light and floor. As you can see, left is the light configuration for kit, and the right side is the floor configuration. Yes, this is the specifications for each configuration. And the right side of the table is their type. You can see some hardware information of the road toolkit. The light kit uses the mini PCI file. Its memory stick is 16G and has a 256G hard disk, and its LiDAR is a 2D LiDAR. The Pro kit uses the mini PCI 7, and its memory stick is 16G and have a 512G hard disk, and its LiDAR is the 16-beam LiDAR. The Pro kit, so you can see that the Pro kit is an upgrade version of the Lite. The ROS versions of the Lite and the Pro kit are both in proxy, as you can see. Okay, and the workspace of ROS 2 kit is located in AgileX directory, and the table shows the main function packages of it, as you can see in the table. Because there are Lite and Pro versions of ROS 2 kit, some function packages are specific to Lite and Pro. We mark them in the table. You can see the widely LiDAR ROS 2 package is for the Lite, and the RS LiDAR SDK package is for the Pro. To the next part, the ROS kit can be developed through the keyboard and the screen display that comes with the kit. It is also able to use the low machine for remote development through the LAN. If you need to achieve remote development, you first need to download the low machine on your computer, and then connect to the router on the robot. Then just enter the username and the password to launch the remote login. As you can see, the above username and password are for the no machine, and both two are for the Wi-Fi of the router. Next, I will introduce some knowledge background of the ROS to you. As you know, although ROS 1 is very powerful and widely used in the robot development, it also has some limitations. Let's see PPT. The main shortcomings are listed in the PPT. Let's take a look. First, the communication mechanism of ROS 1 is based on TCP/IP. It leads to the lack of real time. Second, ROS 1 is not friendly to embedded devices. Third, ROS 1 requires a stable, high bandwidth network connection. And first, ROS 1 needs to communicate through the master node. And if there is a problem with the master node, the entire system may be affected. In the face, the ROS 1 performs well on the Linux, but it's not stable enough on the other operating systems. With the continued development of technology, the ROS 2 has been released, and the effects of the ROS 1 has been improved in some aspects. In this picture, as you can see, it shows the development timeline of the ROS 2. ROS 2 was proposed at the ROS Conference in 2014, and it has gone through 11 versions so far. Currently, our robots are developed based on the 4C, and it's the version we have focused on for a long time. Then, let's pay attention to the humble version. is the latest version of ROS 2, and it's the version we will develop and apply in the future, as this is the timeline of the ROS 2. And next, the main features of ROS 2 are as follows. First, ROS 2 introduced the DDS, means data distribution service communication mechanism. At the same time, it considers the minus nodes and adopted discovery mechanism to make a connection between nodes. And second, it also supports including Linux, Windows, Mac, and the ROS platform. The ROS 2 not only supports the Linux. And third, the ROS 2 introduced a real-time executor to support multi-role communication. And fourth, ROS 2 introduced a security mechanism. It's providing a higher security for robot application. And it also allows the ROS 1 code base to gradually to migrate to the ROS 2 platform. And let's go to this part. I will introduce the examples of mapping and navigation. It includes laser vision, laser navigation, and archive map navigation. The first is, as you can see, the first is the laser navigation. There are two mapping methods, SLAM toolbox, and cartographer. Let's look at mapping with SLAM toolbox. First, we need to start the LiDAR node. Use this command, and there are pro and light versions. Just select it according to your case. And then start the SLAM toolbox. Use this command. And after starting, the map building interface will be displayed in ROS2, like the right picture. And then use the remote controller to control the robot to scan the map. And after scanning, enter this directory to save the map. If there is a window output, map saved successfully, it means that the map is saved successfully. Okay, the next is the mapping with cartographer. It is similar to the SLAM toolbox mapping. And firstly, you need to start the LiDAR nodes and enable the corresponding LiDAR based on your case vision. And then start the cartography. Once it is launched, the mapping interface will also be displayed in the ROS2. You can use the remote controller to scan the map, and finally enter to the directory to saving this map. After the map is building, is the laser navigation. This is the directory where we save the map. If you want to use the save the map for navigation, you need to use this command to switch the launch directory and open the navigation to launch point pi file. And just replace the map 02 point YAML on the line 37 with the name of the map you want to navigate with. And then enter to the workspace directory, you need to compare and sort it. Then after that, you can load the same map in the navigation. And after setting up the map, The next step is to using the laser navigation. There are 4 steps in navigation. Starting the sensors, calibrating the initial pose, providing the target points, and start the navigation. First, start glider. Use this command, and it's same as mentioned before. And then use the command to start the navigation stack, and the interface will appear as shown in the last picture. After that, click the 2D pose estimate at the top of interface to set the initial pose of the robot on the map. Then just click the navigation tool go to set navigation target points, and you can see a path on the map as the picture you can see. Switch the remote control to the command mode. The robot will start navigation. And this is the single point navigation mode. There is also a waypoint navigation mode. It can set multiple target points. The robot will move to the target point sequentially. Yes. And next, let me introduce the on-time map navigation example. First, start the on-time map mapping. Use this command, the first command. And when you exit the on-time map mapping, the mapping fields will automatically save into those directories. And through this part, the usage of on-time map navigation is similar to laser navigation. The steps include start the sensors, set the target points, and start the navigation. First, start the LiDAR, and then start the navigation stack, as shown in the image. Because we are using the facial positioning, so there is no need to calibrate the initial pose when you use the on-time navigation. You can directly set a target point for navigation. The operation steps are the same as the laser navigation. And it also includes single points and waypoints navigation mode. Then, I will introduce the future development plan of the ROS technology. There are 2 parts, humble version and adding the robotic arm. First, let's talk about the plans for the humble version. We plan to start in September and upgrade the ROS version to humble based on the existing hardware configuration. Yes, and we will also add applications such as traffic light recognition, visual tracking, and lane inspection. At the same time, we will develop ROS 2 courses to allow more beginners to experience the joy of the ROS. And about the plan to add the robotic arm, we will develop a robotic arm kit with the configuration as shown in the table. The right side table, you can see the specification of it. And the development will be based on the ROS 2 humble. This kit will have mapping, navigation, QR code recognition, grabbing, and placing location. There will also be a mobile grabbing function demo for you. Yes. And thank you all for listening. With that, our sharing of ROS 2 knowledge kits and the demo comes to the end. Thanks for you listening.